Welcome all of you to this session. My name is Samuel Kamochu. I work with a team that is here. Meliora is the company that I work with, or I work for. Not so sure. But the session today is to look at the power of bytes. And I think on the social media, you've seen me mentioning that our binary protocols are no-go zone for our engineers. And my answer to that question is no. But we have treated it so. And my hope is that we can change that. I know I've seen my good friends. I know Joe Kanywa there from, we used to work in Safaricom. He is quite aware that the core is never touched, and the core belongs to people who are not Kenyan. I know Thomas from Telcom, I can see you. And this is something that we can all confirm if you worked in the telecommunication industry. And generally, all communication is powered by a lot of binary protocols. So if you operate on the HTTP layer, then basically we are limiting ourselves. So the agenda of the day is just to welcome you guys and give you a brief overview of what we have been able to do, because this meeting is marking the end of part one of a series that I've been taking you guys through, the young guys. And I'll do a live demo because that's the basic idea of us being able to play with the bytes. So you'll see how we can play in the bytes and how just playing with the bytes in 30 minutes can open a huge opportunity. And we will also share the plan, what is coming, and the progress update, because we were with you guys 3 weeks ago when we had a pre-launch. And finally, we'll have a Q&A. And before I proceed, I would like you guys to just, so that we get to know who is with us, you can share your name, the organization that you work with, and what you do or your role on the chat. And then we can see how to engage so that we understand who our audience is. So I'll move on to the second part, which is about Ntujenga. So the whole idea about Ntujenga, this word is borrowed from our national anthem, and it says Ntujenga taifa letu, ndio wajibu wetu. And that's what we believe in this program, and that's what the team at Meliora, who are spearheading this initiative, believe in. So the idea is to bridge the gap. I had a conversation with my senior here, Mr. Kanyo, Joe, one day, and I was telling him that we all have a lot of information that would be more useful if transferred to the younger generation. So Ntujenga is all about that. And we are promoting the culture of sharing. So it's not about Kamochu doing the love the bytes protocols. It's what I believe could impact the next generation. You guys know what could impact them, and we're inviting you to come and share so that they are fully empowered. Then we want to be the jetty. Yesterday I was at Nairobi Innovation Week at UN, and I remember some of the students asking, technology is so wide, where do I start? Do I do big data? Do I do analytics? Do I do data science? Where do I start? And we want to be that place where these guys who are confused can come and find their way through the initiatives that we are going to offer. And you guys, I believe, will make it possible. Then the other thing is about democratization. We all know that Udemy has very nice tutorials, and nothing against Udemy, but trust you me, the guys who are struggling to buy a meal, 30 shillings in campus, paying $10 is a tall order. So our belief is that this information is more useful if it gets to the people, and we should not create any barrier. So we should not have any paywall for the students, at least. Maybe you guys in the professional space, you can pay, but the young guys in campus, let's do it for them. And one day we will come and reflect on our contribution to their lives. So that in a nutshell summarizes what Ntujenga is all about. And this is not my idea. Some of you have been here. I know Dr. Okeo has worked with me all through. He was among the first guys to join. He was my lecturer, and he's a lecturer at CMU in Rwanda. And this is not my journey. It's the journey of you guys, but I'm here to just represent you people. The first thing that we did for those guys who have not been part of the journey, we started with what is digital. And the whole idea was to tell our people that digital is all about digits. Computers don't know anything else, it's numbers. So if you send the word hi, that H and I characters, it's a hoax. We never send it. So all we do is we have to find a numeric value of each of the letters and we send it through the network. Same case applies to audio, same case applies to images, video, and all those things. So that's the basic principle that helps us to start this journey of unpacking the bytes. Now, we all the guys who have been working with me, they know what encoding is. It's just that process of converting the original message into numbers, and decoding is the reverse. So codec, still same conversation if you're dealing with codecs. So that's something that we shared with the team. Then we went ahead and we taught our people how to count. 1, 2, 3, you get to 9, then you move to 1, 0, or we call it 10. And we tried the same with hexadecimal, 0, 1, 2, 3, up to 9. Then we started counting. 10 becomes an A all the way to F, which is 15. So we learned about a bit, a byte, or what we generally accept to call an octet, 8-bit, a nibble, 4-bit number, half a byte. And the importance of the nibble was because a nibble, being a 4-bit number, can take values 0 to 15. And that means a nibble can be represented as a hex character. And finally, we touched into the word. Computers don't move bytes, they move in batches of bytes. And if you're dealing with a 64-bit machine, that takes you to the word is 64-bit. The registers, the buses, you might find that they are following probably the word based on the architecture. So our guys don't fear hexadecimal characters. That was my first thing that I wanted to ensure that you guys don't fear. And when you see hexadecimal character, just assume it's 4 bits. And that's what we did. We went into character set. We went to the journey of ASCII. We went back to the history. We realized how ASCII was insufficient. Guys tried to extend it. Guys in GSM tried to do other things like GSM 03.38, which is GSM 7-bit, still not sufficient. Then the world decided to go to Unicode. And now we started saying that every character has to be given a code point. But that code point, the problem was the code points were not bytes, just like ASCII, where each and every number could be given a numeric value. The code points were not numbers, and you could not represent them in binary. So you needed something called Unicode transformation thing. And that's where Unicode transformation format, UTF-8, 16, all those things, you guys have seen them in the video. And then we talked about little and big endian, something we learned in computer science back in campus. We have never applied, but I was able to show you guys how that thing is relevant today. Then the next thing is Boolean logic, which at the end of it all, I just wanted you guys to be comfortable with bitwise operations. So that's what we did. So you need to know AND, OR, XOR, and how those things are very critical in our manipulation of bits and bytes. So, and that's what we covered. In the last 3 weeks, we've been able to make some serious achievements. These are small wins to some people, but for us, they're huge wins. We've been able to have content, 2 hours and 59 minutes content on YouTube, on our Ntujenga channel. We have 14 videos, 13 episodes, basically 12 episodes plus the bonus one and the intro video. We have 176 subs. Thanks, guys, for supporting us. And the views are there. We've been able to do 2 webinars. This is the second one. And on our WhatsApp group, we have 167 members as of this morning. So these numbers are as of this morning, and we really appreciate your love as you love the bytes. So that brings me to the end of that intro part. I hope I've done in 10 minutes. And now we want to go and deal with the bytes. The thing that I need to make you guys understand is, in the event you do not understand something, it means that you have not watched the videos, and we will ensure that you watch them. And after the demo, we will show you how. And we know your tricks, and we know what you guys can do. And we know what we can do to ensure that you read. The task is to decode a protocol that we are so familiar with, but we probably don't know it a lot. It's called the IP protocol. So the protocol in question is called the Internet Protocol. It's a document that was done in September 1981. And most of you have not read it, but you keep talking about it. The thing that I want to challenge you is that it's a short document. It will not take you a weekend to go through it. And if you go through it, in the words of one Brian Kitunda, who is in this call after he went through the RFC for HTTP, it's called the request for comments document, which is a document done by IETF, the body that is in charge of the internet engineering task force. And all the protocols we can think of, there is a body that drives those protocols. So this document is short. We'll not read through it, but when you read this document, you'll understand what routers do, or routers, depending on which school you went to. But in our case, we just want to go and look at the HTTP header and look at the various parts of the HTTP header. And I'm going to do a live trace. I'll capture the network trace on my computer. We will get the dump, the hexadecimals, and we are going to write code to decode that and break it according to this protocol specification. So that's what I want to achieve in the next 30 minutes. I might not decode every part because some of them are redundant or they're repetitive. So once you know how to figure out time to leave, you can actually figure out the total length. But I'll try as much as possible, if time allows, to get the various values as you can. One of the things you'll notice that this document is in lines of 32 bits. So in this document, 8 bits is what we call a byte or an octet, and 32 bit is what they call the word. So if you read of the internet header length, is the length of the internet header in 32-bit words. Remember, word is a 32-bit, so 32-bit is the same as 4 bytes. So that knowledge, we will apply it somewhere when we are looking at something called the IHL, or the internet header length. How many octets and how many words are there for this internet header? The systems that use this document to operate the routers and things that operate at layer 3, I believe, yes. And this is something that is very beneficial to them. So I'm going to start something on my machine. So there is a tool that you can use called Wireshark, which can actually monitor packets within your laptop. So I will come here and run Wireshark. So once you open Wireshark, I don't have the latest version, but this version actually works. So you'll see all the network interfaces, including the LO, the loopback 127.0.0.1. But for now, I want to open any of the networks. So you can see on my machine, you can see the packets that are being exchanged. And guess what? The UDP packets are because of this stream that we're doing. The voice and everything I'm sending is being sent using UDP frames. At the transport layer, they're using UDP. So, but don't worry about those things that you're seeing. So the key thing that I want to do is I have a small page that I've created, and I can open it on my browser. So allow me to open it here. And this is my IP. It says, hello, Ntujenga. All I'll do is I'll use Wireshark to just capture this. So I'll come here and say, Wireshark has filters. I can say, I want packets that are involved in this address. Let me try something else to access a web page using wget. So I'll come here and open another tab, and I'll use wget to access the web page. And one of the things you'll notice on Wireshark, you can see this. Don't worry about these frames that are being exchanged. In the next section where we'll talk about protocols, we will actually look at each of them. But the key thing is, I want to use Wireshark to decode this request, the GET request. All of you who are doing web development, you know what is a GET request. So this is the IP header, and we know that the IP version is version 4. Source IP, destination IP, protocol is 6, time to live is this, and this is this. So essentially, this software that has been written by the Wireshark team has been written with the knowledge that we're going to apply today. So I'll come and copy the hex stream. So I'll copy this hex stream and I'll paste it here. So this is my hex stream. So this is essentially the IP header. And if you can see here, these are 40 nibbles. Please note, these are 40 nibbles, or they are basically 20 octets. And we will look at it. The header length is 20 octet. We will discover that as we proceed. So the key idea is here there are flags that we have to look at, and this Wireshark tool has already decoded the bytes according to the RFC are specified here. So we are going to write code to decode this. And the next thing I'll do is I'll come here and I will just do new. This is in Java. Please note, my preference would have been to use C, but sijafika hapo, so don't worry. So I create this. For most of you, this is not a big challenge. So I'll do public static void main, and Dr. Okeo allow me to enjoy a bit static, as we used to say in those, I think 13 years ago. So, so I'll come and create a byte array. So let me call them bytes, an array, and I'll say new byte as an array. But since I know this, the key thing you need to note is that 2 nibbles is an octet, so it's a byte. So what I do is, because this stuff is in hexadecimal, in Java you use OX, basically the X to mean that it is hexadecimal. And I can actually come and take 2 nibbles, a hexadecimal, 2 nibbles, a hexadecimal, 2 nibbles, a hexadecimal. So the idea is that when you're receiving the network packets, you receive them as an array of bytes. So everything actually in computing is bytes. And for the sake of argument, I will break every 4 of them. I'll break them so that we can deal with the words. Please, you can do OX to mean hexadecimal. You can do OB to indicate that the number is binary. So if you don't put anything in front, we assume it's an integer or it's a decimal number, essentially. So 4 of them, 4 of them. Now, the key thing I want you to note is that if we say this is 45, you already know that 4-bit number, you have 0, 1, 0, 0 because of place values, 1s, 2s, 4s, 8s. So you know that this is 4 and you know this is 5. And guess what? Let me look at this number here, the last number. D is the same as what in hexadecimal? Joanina, I heard you speak. D is, A is 10, B, C, D. D is 13. Yes, D must be 13. So it's supposed to be 1, which is 8, plus 1, which is 12, 8, then that one. Now, and then we know 2 is 0, 0, 1, 0. For those of you who can remember stuff to do with binary. The reason why you are seeing my IDE making noise for some of them is because of something called 2's complement. This number is bigger than 127 because technically this number is 168 and bytes don't go beyond 127 in Java because Java uses signed data types. If you don't know what I'm talking about, please revisit the videos and these things will make sense. So anything whose the first bit is 1, it will cry. And our work is to typecast so that we suppress the IDE's noise making pattern. So we have already our bytes as an array. So I'll go very quickly and we will look at the header. So the first thing is the first 4 bits represent what we call the version. So I'll come and say here is version. And the idea is I know I have the first octet, so I can come here and say the bytes. And for those of you, you start with 0. What I'm going to do is I will take this number, and because I know this number could, to make our code much easier, you can expand it with OFF so that you deal with 2 complements issue. So don't worry, you'll go and read about 2 complements issue. But the key idea is to ensure that if you do this is a byte and this is an integer. So the moment you do this operation, it becomes a 32-bit number. And a 32-bit number, it means that you're now able to have the first digit, even if it was 1, which would have been treated as a negative number, we are basically able to convert it into a positive number, which is what we want to do. Then, since we know that this number is like this, so one of the ideas that you can do to pick the first 4 bits, because you have a byte, how do you pick the first 4 bits? One idea, you could do a mask like that, and then you shift. But one of the things that we learned is you can actually do a shift, the bits to the 4. So what will happen is that this bit at the first position will come here, and the second bit will come there, the third bit will come there, and the other bit will come there. And where they are coming from, we will have zeros. Basically, you've been able to shift the number and now moved these 4 bits to here. If you come here and do a out, which is what I want to do, you'll basically be able to get the version. This is one of the bitwise operations that I told you guys to look at. And if you do that, we are able now to programmatically know that this is IP version 4. So as we wait for my computer, so we know the version. So the next thing, which is the next challenge, we want to come and discover the IHL. Remember, the IHL is still on the first byte. So IHL is the internet header length. And we have known that it is the length in words. And we know our word is 4 bytes. So what you're going to do is, we already know that the number looks like this. The number looks like this, 0100, and this one was like that. So how do you get rid of these last bits? Because you want to get rid of this. So what we will do here is we'll use the mask. So you come and do 000, and then you do 111, and all you need to do is to AND this. And you guys know, 0 and 0 become 0, 1 and 0 become end. You know that logical AND, or the bitwise AND. And then you have these ones will be retained. So these essentially will give us an answer of 0000, because the mask has cleared the first one. And then you have that. That number is what we need. So what I need to come here and say, I'll do IHL, and this is in words, just to differentiate, because remember, since we know the words, we also need to know the octets. So the IHL in words will be, again, I come and do bytes. I take the first, remember we are still dealing with the first byte. I'll do with OXFF to ensure that I take care of 2's complement. If the number was negative, we deal with the negative issue. And all I need to do is to AND it with a mask. But what mask are we going to do? Since I want to write the code in binary, I can say OB000111. So you write that, and I hope these are 4. Remember, the OB is not part of, it's just a notation to help you know that this number is not a decimal number, it's a binary number. So if I do that, and I AND the 2, the answer will be the value that we want to get. So I can come here. Please note, by doing that, we have the IHL in 1. And I will also come here and do the header length in octets or bytes. So basically, it's the IHL in words times 4, because we know that 34 bits is the same as that. So I can come and do a out again, and I come and get that value. So up to that point, you've seen how bitwise operation called a mask can actually do these things. And spoiler alert, if you guys are developers, you've dealt with SMPP, the code that deals with that, we can confirm that if you go to the open source libraries, you will find these things I'm telling you here. And you have not been doing them, and we know that it is bad manners, because you need to be doing things in all spaces. Total length. Type of service, I'll not look at it, but you can try out. It's a 16-bit number, and I will not look at it for now. Let me just go to total length. So I'll look at total length. Now, total length is byte what and what. So you have, this is 1, 2, 3, and 4. So we are going to use index 2 and 3 together bytes. So what we'll do is we'll come and get the first byte, part 1 of total length. We know that those actually total length is these 2 bytes. So we already know, because it's the first line, the last 2 bytes. So because I've ordered them that way. So the key idea is, how do you convert 2 bytes, because 2 bytes are like 2 variables, into 1 integer. So that's the idea. So I'll come here and say total length. By doing this, you already know, guys, that, and I'll use hexadecimal. This is the same as OX000000. So basically, an integer is 4 bytes in Java. So by declaring that, I have that one. But what I want to do, if you guys work with me, is that I want to copy these 2 and I put them here. And I want to copy these 2 and I put them here. So the final answer that I want is O, and then you have 00, and then you have D2. That's how we create. This can be a bit confusing, because we have just copied the 2 bytes into 1 variable. So what we do is we use bitwise operations. So the key thing is I'll come here and say total length is equals to, I'll take the first part, and this is byte 2, and I will and it so that I can deal with the negative scenarios to make it unsigned. If it has a 1 at the beginning, it will be a negative number. But remember here, we are not interested in the negative number. The length can never be negative. And then what I'm going to do, I am going to OR it with the total length. Remember, my bytes are 0, and I'm going to OR it in the total length. By doing so, I'm basically copying this byte into these 2 positions here. Now, but remember, I want that byte to go here. So all I do is I shift 8 positions. So that now, whatever I copy here by doing OR, the bitwise or the logical OR, if you guys can relate, then I shift it 8 times to the left. So by doing so, I've already set those 2 bytes, these 2 octets correctly. So then the last thing is to come here and say total length, and I say is the same as the total length that we got from the previous side, and I OR it with now the second byte. But as I do so, the second byte is index 3, and all I need to do is I can ensure that I deal with OXFF to ensure that I deal with a negative scenario. Here, when I OR, if you know OR, it means that since our value was 0 at the beginning, everything that is 1 will be retained as 1, and everything that was 0 will be retained as 0. So you can go play a bit, but the key thing here is I want to come and say total length. So remember, the IHL was the length of the header, but the total length is actually the header plus the body. So if I come here and run this, I will discover that the values that we have are actually 210. And if I go to Wireshark, you can see that the total length was 210, the version was 4, the header length was 5, and it was 20 bytes. Basically what we have in our code. So basically we are allowing you to become the guys who can write Wireshark or a trace viewer. So let's move on to identification. I will not do identification. It's a similar thing like total length. So I'll not do the identification. I'll go to the flags and the offset. Now, this one is very complex because we have 3 bits, 6th, 7th, and 8th in the second row. They are representing the flags. And then 13 bits are representing the offset. Together in total, 16 bits, meaning 2 bytes in the second row. So I go and pick this and this. The second row, I pick these 2 things. This is what we want to decode. And you're going to decode it as flags, which are 3 bits, and offset, the fragment offset. For those who know much about IP header, you know there is a concept called fragmentation in layer 3. So these bytes will be, because this is supposed to be 7 and 8, so it will be 6, 7, the index. So I need to look at this index, because remember it's an array 6 and 7, because it's the second row. You already know that every row has 4 bytes. So the last 2 ones, the last 2 in the second row are 6 and 7. So the key idea is allow me to convert this into binary so that we can understand. So 4 is essentially, and I hope you guys are working with me, 0, 1, 0, 0. The 0, the next nibble is 0, 0, 0, 0. And the last ones are like that. Now, what these guys are telling us is that this is broken into 2 parts. And the first part is that part. And each bit has a meaning. And I will not open the document. I'll open Wireshark because it tells us. The first flag, the first bit is result. And the second one is do not fragment. And the third one is more fragments. So if you have fragment set to false, which means you fragment, because when it is 1, it says do not, then you can have more fragments. And of course, this becomes now the fragment offset. You guys know what fragmentation is. It's just breaking down stuff. And with this stuff, we can actually get to know whether we've received all the fragments or not. So don't worry about that. So let's deal with the first byte. So we are going to check. I want to check 2 flags. And the 2 flags are Boolean. Is it do not fragment, whether they are set to true or false. Of course, we know the do not fragment is set to 1. So here we will leave it as is. And then I will also pick another flag, which means more fragments, whether there are more fragments or not. So when the router receives this information, it has to figure out. But remember, the byte, if I can write it here, is 01000000. Now, remember, do not fragment is the second bit. So what we do is, when you're using masking, we write in such a way that the bits we don't need, we set them to 0, and we leave the bit that we need set to 1. So basically, that's what I do. And the next thing is, I will come and check more fragments. It's the third bit, so I can do that one. And this is my mask. So this is what we call the mask. And here we'll also have the mask for this guy. So if this stuff doesn't make sense, we will try and have a follow-up session, but you need to go and watch the video. Again, I will expand it with that one to ensure that I deal with the issues with that. But then the next thing that I'm going to do is I'm going to mask it. I'm going to AND it with a mask. And the mask we know now it's 0, 1, 0, 0, 1, 2, 3, 4. Now, once we do that, if the second bit is set to 1, this thing will be more than 1. But if the second bit is set to 0, this thing will be 0. So all I need to do is to say that if I mask and I get a value that is greater than 0, it means the bit was set to 1. And I can do the same here and say that more fragments could also be, if the third bit is set to 1, this value will become greater than 1. And I do that. So the key idea here is I can come and now print this. If this is not making a lot of sense, don't worry. It's simple stuff, but we need to ensure that we walk through because we have started a long journey to do that. So basically that gives us fragmentation. And of course now the last part, which is now the offset, which is an integer, which is now the hard bit fragment offset. Remember, we have to take the first byte, just like we did the total length. So we'll come here and do this, and we're going to shift it. But before we shift it, we have to ensure that we actually remove the first 3 bytes with a mask of 1, 1, 1, 1, 1. So essentially what we are doing by this is, yes, we take the first byte, which is byte number 6. We make it unsigned. So that becomes 32-bit, and the initial parts will be zeros. And then what we do is we mask it so that we get rid of the 3 flags because they are not necessary. And that byte, once we get it, is what we AND it with the fragment offset, assuming that the fragment offset here is set. Actually here I can just say int fragment offset is equals to 0. Then I can come here and do that. Actually, it's redundant. I didn't need to do that. And for those of you who know how Java deals with such stuff, I can do that to say that it's fragment offset. You OR it with itself together with the answer. So what we've done is we have actually picked the first part and we are going to pick the second part. But the second part, we don't need to mask it because we need all the 8 bits. What we've done here is we've picked 5 bits from the first byte only, and we've done so by ANDing it. Actually, this is AND, so that we lose the first 3 bytes. So we AND it so that the first bytes are reset to 0, and then we are left with the next 5 bytes, they'll be set as that. Then we shift it, and then after shifting it, we are able now to do this. So the key idea is, if you get confused, the key idea that I want to tell you is that if your lecturer taught you bitwise operation and you thought they were useless, you are wrong, because we need to get into this space. And you might think that I'm doing magic, but at the end of the day, it's stuff that is easy to do. So if I go here, I can look at our fragmentation. Do not fragment is set to 1, so it's true. It's not fragmented. More fragments will be false, and the fragment offset will be 0, as this guy has indicated. And then, of course, I can now do time to live. I'll not do time to live because of time. Protocol, this is 1 byte. All you need to do is, actually I can do TTL and int TTL. All we will do is we will come and say bytes. These will be, if this is 7, then you have 8 and 9. TTL is 8. And all I need to do is I AND it with FF. And when I do that, now it becomes an unsigned number. And that way I get the TTL. Then the next one is protocol. And protocol, now I pick byte number 9. And I do the same because it's 1 byte. Then I get a number. And then I get header checksum. That one I'll not do it because it's 2 byte. You can repeat the same logic here with total length. And you can now use the right byte. And I will now go to the last part, which is now getting the IP address from the nibbles that we have, so that I also have time for the last part of this episode. I hope you guys are with me. I am not alone. That's my hope. And then the last thing that we want to look at is the source address. Now, source address is 4 bytes. I will copy this and I'll just deal with source address here. And here I will illustrate that thing of unsigned. So we know that the IP address has many parts, 4 parts. And you know that it's 4 bytes. This is 32 bits. And each byte, this is IPv4, is up to 255. So you can have 0 to 255. So what you're going to do is I'll do part 1. So I'll take bytes. I'll pick, because this was 7, 8, 9, 10, 11, 12, 13. I'll pick 12 to be part 1. And I'll pick the other 4 parts very quickly. So I have part 2, part 3, part 4. And here I'll do 3, 4, and I'll do 15. So that's it. So if you guys want to look at an IP address, you know, source IP is essentially part 1. I'm not going to use string builder for those guys who wanted me to use string builder. I'll use this concat. Then part 2, and you put a dot. So remember, when you're sending the IP address over the network, we don't send the dots. We just send the parts alone, a dot. And then I will put here the last part, part 4. So an IP address has 4 parts. And now we know that. What I'll do is I'll come and do source IP. And I put that. And I will come and concatenate with that. And I'll do that. Now I want to show you, because now what we've done is we've taken each part of the byte. Remember, a byte is also a numeric number. It's like an int, a long, a short, a byte. All of them are numeric values. If you want to store a hexadecimal number, you can do OX55. But if you want to store 23, you can just say int, you can say byte A is equals to 2. That will also work. And you can also say byte A is equals to 02. Or you can also say byte A is equals to 10 if you're dealing with binary. So don't worry, a byte is a numeric number. So it's still a digit. That's why it's digital communication. And if you use the word digital transformation in your pitches and you don't know this stuff, you need to pay us. So essentially, if you look at this source IP, oh my gosh, you can see that the IP address has negative values. And the reason is because C0 is represented as 1100, because I know C is 12, and then this. But if you have this number in signed data types, anytime you have the first bit set to 1, it's a negative number. So this is a 2's complement. For those guys who have heard about 2's complement of 64, gives us that. But now, for us to deal with it, I said all you need to do is you AND it with OXFF. And what it does, it makes this number an integer, because by doing computations, like if you say in Java, 2 plus 3, without you saying, the answer must be an integer, meaning it's 4 bytes. So by doing so, you're increasing this into 32 bits, and you're adding many zeros ahead, and the first bit now becomes 0, and the number becomes positive. So essentially, that's how you can convert a byte which is signed to unsigned. So this is stuff that is not too complex. It might be complex to you if you have not prepared accordingly, but definitely I'm happy to work with you and do this stuff. So essentially, we have all the skills to decode all the parts of the IP header. I know I didn't decode differentiated services. There you are dealing with bits. You have to deal with each bit, what does it mean? Head, source address, and the destination address, they are almost the same. The reason why you saw that this number was the only number which was 43 positive is because this is 43. The rest, they are bigger than 127. A byte is negative 128 to 127. That's why they're giving us negative numbers. So all you do is to do this, or you can use another thing in Java, an inbuilt function to say byte dot to unsigned int, then you pass your byte. So we can try this for the last one so that we also see that there is also another way to actually decode the byte without having to do bitwise operations. But guess what? I wanted to use bitwise operation because this one is an abstraction that does exactly the same thing. Why is it making noise? I will leave it and we can try that. I think it's probably the JVM version that I've given. So you can see, voila, we have now IP address printed correctly. So if you put all these things into an object in Java, so you can actually receive a stream of bytes, you put them into an object, and now once you know the source IP and the destination IP, all the router does, it goes to the routing table, checks the routes that are there, and determines what to do next. And everything the router does is just manipulation of bytes. If you want to create solutions like deep packet inspection solutions, you know, trying to see whether you've been hacked or trying to detect DDoS stuff, you can actually go and implement such a thing on your routers or proxies, and you can actually detect these things. So they are doable, they're not difficult, they are numbers, they are better than calculus, ODE, or even those as x approaches 0, the limit of something. So you need to ensure that you get these basics right. So that brings me to the end of that session. If you look at Wireshark, we've decoded the stuff as Wireshark did. So if you want to do the destination IP and the source IP, you can still do the same, and that will take us to the same place. That actually there is no additional knowledge in just doing that. So the key point, and you should not forget, is that with the bitwise operations, which is not complex stuff, only that it might be because I just introduced you, ambushed you with a lot of stuff, but you can actually decode a bit and a piece. And I'm saying this because I've worked in the telecommunications space, and I'm going to repeat this, that all the core network elements, whether it's HLR, all those things, the reason why we don't build them is not because we don't know how to deal with threads, scaling, deploying, and all those things. It's because we do not like doing AND, XOR, and we don't want to read this document, which is short. And I'll challenge you guys to go and read and do this thing. So that brings me to the end of this part. And now I know I've used more time than I had allocated, but I believe that prepares us now to go to the second part, which we will basically talk about what next, and I will give you guys some few minutes to ask questions. I'll mention of what is next, and the key thing that is ahead of us is a thing to help you watch the videos. I know some videos have 50 people who have watched, and yet you guys are more than 100 in the groups that we operate in. So the key idea is that on May 12th, we will have a hackathon. And the hackathon will assume that you have mastered the bitwise operations, and we will give you a task. And that task, as of now, as I was joining this call, we have a commitment of 100,000 Kenya shillings that will be won in 2 hours. So we'll give you a challenge, you will hack it, and we will give you this money. So 100K is gone, and there are people who are pushing so that we can push the prize money to 200K. Because once we do this, then you guys will be able now to have the power to build the routers, to build the protocol stacks. And I know, Joe, you're listening. We need you guys to come and support us and ensure that these young guys can do what we essentially say research and development. So this is what we want. And guys from Microsoft, Google, Safaricom, everyone who is in a place, Telcom, kujeni mtusaidia so that we can start doing these things. And I believe we can have hackathons now to decode some protocols and build frameworks and now start building those systems that we don't create. The idea will be to be given a set of challenges. And sorry, before I move on, the money is there. The money will not be won by one person. There are many guys who are going to win, but definitely the first guys will win. And the challenges, we are working on the finer details of how that thing will happen. It will happen online. So you guys will join in. The first person to finish. We'll have the category for students and the category for professionals. And of course, the big money will go to the guys who don't have jobs. They're either in school or they're looking for jobs. So if you're looking for jobs or you're in school, you fall in that category of students. So you can go home with the big money. And the idea is that whoever finishes first, we will be able to give you this cash, and it will be transferred at that particular point. So we are not going to have things. And I hear there are also merchandise and that, those hoodies, t-shirts, and who knows, Safaricom might give us funds. I hope they are watching. Yes. So that is it, what is coming. And the plan is, as we had mentioned, we said that we are launching the Ntujenga channel 3 weeks ago. We did. We said that we are curating content for the Ntujenga platform, which is our video on demand, to ensure that we democratize this thing and we create the connections that are required for us to create the teams to do the job that we want them to do. The first community webinar, we have done one. We are hoping to invite more guys. You guys who are professionals, you need to come and tell us. I know in the group guys are asking what, this is not about bytes and binaries. It's about Spring Boot. It's about what KCB is using. It's about what Safaricom is using. It's about what Telcom is using, Microsoft, Google, and many other companies that are out there. So these guys will come and tell us what technology works for them. And we will definitely take the time to ensure that we have content in that line. And when I say we, I am trusting that the community guys and the professionals are willing to come and do what I am doing. So we still have a pending launch of our online platform. We are curating the content for guys who want to get started. And we have content we did last year when we did 6 months of Ntujenga season 1. And that content will definitely be available on the platform. It's not on YouTube, but it will be there on that e-learning platform that will allow you to learn that stuff. So we'll also have university outreach and hackathons that are still in the future. So essentially, I want to thank you all, and I want to tell you that we have the desire to ensure that we empower the next generation of software engineers by equipping them with their skill sets, which is what you're doing today. Mindset, to know that we go to school not to make money, but to fix problems, and many other things that we need to change. And then, and of course, we do what we do not because of ourselves, but for others. Those are mindset stuff that we need to keep reminding ourselves. Tool set, those OCPs. I know Joe is here. I don't know whether Dan joined, Joe's colleague. And the key idea is we want these guys to know OCP, Kubernetes, and all those things as soon as possible. And I'm hoping that you guys will give us a platform to launch and to host those things for free, Joe, if you're listening. So thank you very much. And I think we are 1 hour done. So I would like you guys to move now to the question and answer sessions. Yes.